in the next session of the geometry of transit line. The word or the term geometry actually refers to the framework of the routes which exist in any city and its transportation system. So this is basically the location which we identify as a different nodes, as a different networks. A geometry is a single, is the combination of the different link between two nodes. And between those two nodes, the same length is called, the same line is called route. In the transportation geography, it is very common to identify several types of transportation structure, which is actually about to build in any city, which linked with transportation network such as nodes, links, hubs, or corridor. So how the city actually looks like is called the geometry of transit lines. In the today's session, we will mainly talk about the line alignment, the line lengths, and what are the different type of independent and integrated lines. Coming to the very first point of our lecture today, which is line length. As you can see here in this figure, you can see here from this origin to the destination, which is denoted with green and red color in both figure. So this one we call the line alignment. A line alignment means that where the transportation service in the city will go through. Actually, it is the geometric network of the set of different connected of which is combined with different edges, different junctions, along with the different connectivity regulations, which usually represent or model it according to the behavior of a common network. So the transportation line is actually the organization of any transportation system or within the city. They have the same line will actually pass through in each and every corridor. Line alignment will actually we draw that line for two basic purposes. The first one is that what type of collection and distribution of passenger will be exist in the same line alignment. Means the same line is crossing or passing through neighborhood areas, residential areas, or do we have any demand or not? So this line alignment we actually determine or collect the total passenger demand as well. And it will transport or passenger or a long distance or a long haul. So means that it will provide the service is a origin and destination to deploy or to transport the passenger as well as goods or a large distance. The second topic of the today's session is about line length, which is quite clear from its name. The length of a line segment, which can be measured by measuring the distance, such as starting point and end point. Basically, it is the path between the 2 points according to the length or so for example, if we would like to see that what type of line segment or line length we can be found, so we can do that by the distance formula between starting point and the end point. So this will be its line length. But if we talk about the advantages, so the line length, if the same line is extended at a large area, so that will provide the more direct trips, and there will be more preparing for the more time for the transit unit to prepare themselves for the next trip. So means while not going from the origin to the destination, but when they will reach to the destination, so according to their duty roster, they will have enough time to turn back and then go from the destination to the origin. But if we talk about the disadvantages, for example, if there is any type of a failure, accident, or mechanical breakdown of any transit unit, so we might receive the delay propagation. So you can imagine if we talk about here about the tram network or light rail transit, which only goes in a single path and we have only single track. So if there is kind of a mechanical breakdown, so of course the same track is reserved. So we will receive the delay propagation. And the important thing is the run cutting can become more difficult. What is run cutting? Run cutting is the term which is used when the transit unit lost its time due to any reason. If that could be accident, that could be kind of a mechanical failure because more passengers are actually waiting at the same line. So to cut the same delay, that will be more hard and complicated. So this is the typical example of that how the line length should look like, as you can see here. So in the city center to a bit in the outer ring, we have only mass rapid transit line, and then we have multiple bus lines, which actually work at some places is a feeder network, while in some places it work is a branch line. So you can see here in this straight line, all of them will actually work as a main line. But when they will cut into the single or only one line, which will only serve the specific area, then we will call them branch line. So its advantages is that we have the high utilization of the offered capacity. But if we talk about the disadvantages, so you can imagine that in your city center, we have 2 kilometer or 4 kilometer where we have the very much dense population is covered with the mass rapid transit, but the rest, all of them is covered with the buses. So you can imagine that this mass rapid transit will be constructed in the underground system and the same traffic even you cannot see unless you are not at the tube station. But if we talk about those buses, so you will see a lot of buses, that bunch of buses are actually going from here and there. So its big disadvantages will be to change to transfer from this MRT line to the buses lines. For the person which is kind of anonymous or a new in the same city, I mean, anonymous doesn't mean, I mean, like the person who is not even familiar with the city transit and transport network. So he might have a bit confusion to, for example, go to that specific location. So which bus is going from which station? So there will be issue with the transfer to the feeder network. And there we have the major section of the trunk is served with the buses. So like almost 70% we have buses, as I already mentioned. So the bus lines are usually considered a bit less efficient when we talk about the dense population. This is the typical next example where we have the majority of the same line is covered with the mass rapid transit. So of course, its major advantage would be that passenger can go with the direct and very quick, and they will maybe not need a transfer in the main city to their location. But its disadvantage would be that near to the city center, the per per person cost or the passenger cost per person in any transit mode would be quite economical. But when it's go from the away from the city center, so we might does not have that much Capacity, of course, capacity is there, but we might lose the passenger attraction. So this is the disadvantage. So now the question is we already mentioned that when we have the half mass rapid transit and then buses, that part was also end up with disadvantage. And the one where we have the mass rapid transit in the whole city, we still have issue. So what we should do? The very important thing is that we need to construct the different trunk lines into different branches according to the population and density requirement. Okay, so you need to have a look that where exactly your residential blocks are located. So that part is quietly recommended to cover with the mass rapid transit. The rest area should be covered with the buses, which will play a role of a feeder or branch lines. Now we are talking about the optimal length of any radial line. So the optimal length of radial line in any suburban, we can determine that with considering different criteria. The first one would be if it's providing the maximum passenger convenience and comfort to the people, and then if it's able to attract more ridership, because when we will have more ridership, so that means that our cost per passenger per kilometer will be quite economical, and it will also reduce the need to construct more parallel highways. Okay, and if we compare that with the longer trunk lines, which also include or maybe required that more additional investment is needed for the purpose to reduce the operating cost, because mass rapid transit actually replaces a very large number of labor intensive bus operations. So you can imagine that the same mass rapid transit MRT, which can hold the capacity of over 1,000 people, have only one single driver. And if you compare, if you put the same capacity, and if a single bus have a capacity for about 60 to 80 people, so of course in every bus we might have one bus driver or maybe conductor or maybe security person as well. Which best example is like most of the places in US, in China, and so on. Okay, but in Germany, if we talk about, so those does not have any conductor or security person. So because they have completely open type of a network, so you can just punch in your card or buy the ticket within the same line, so you can get in. Okay, so through mass rapid transit, we can reduce this intensive requirement of the maximum requirement of different bus operator as well. And it's another advantage is that we can diminish the ridership density, maybe decreases in the low density area. As I already mentioned, if we end up with the mass rapid radial line, which is usually work is the main line. If we construct the same line in the area where we don't have any residential complexes, any neighborhoods. So if we end up there with the mass rapid transit, of course, we will not be able to attract passenger to go there. So we might end there with the empty run, so which is not economical. As you can see here, this is the one typical example before to go in the independent and integrated system. This is the example of Germany. So you can just have a look at how the transportation network in the city actually look like. As you can see here from like this point to like that point, we have completely mass rapid transit system, and then it's again connected in the vertical interface as well, and then at the different angles as well. So some of the part is connected with the tram, and majority of them are actually connected with the buses, which work as a feeder network. So the next topic is about the interconnection. Interconnection or interconnectivity is very much important, that how we can connect two different, for example, mass rapid transit connected with the uh, bus rapid transit with the BRT, and then BRT is connected with the regular buses, and then regular buses is connected with any other transit mode. So we are here talking about 3 to 4 different integration of those transit modes. So how we can connect all of them together for the passenger comfort and maximum accessibility. Independent, which is quite clear, so which does not share its path with any network. So they will provide the very much straight and direct kind of trips. So it have also its own advantages, but if our network is more integrated, so we will have maximum advantages in terms of the capacity, in terms of the maximum utilization of the same network, as well as of the cost of the investment cost as well. If we talk about independent lines, so independent lines are the line which does not overloop or connect with anyone. So it's quite simple to operate. So like your mass rapid transit will use a very same network always from one way to another. And then while coming back from the destination to the origin, then another network is built for that. Another line length is built for that. So of course, if we have the utilization, if we require more people need to be kind of transported, so independent line have that capacity. But if we talk about integrated line, integrated or is the line which have multiple branches, which converge, which diverge, which also provide different overloops within the same area for the purpose to provide the any type of a transit unit activity in the same line. So independent line or majority of them have a very straight alignment, but the integrated one have that could be possible in any shape, and we can fit different schedule according to the different passenger volume, because we can increase its capacity if we are talking about integrated one, because mass rapid transit are connected with the light rail transit. Again, it's connected with the tram, which is connected with the bus rapid transit, which is connected with the regular buses. So we have 5 to 6 or 7 different type of a transit units function together at the same time. But if we talk about independent one, so they might have issue with the connection in connectivity with the other transit unit. Of course, integrated line usually offer more direct station to station service. For example, if you are going from one origin to the to like any type of your own choice destination. So if the same line is not going there directly, so you can transfer it to any other mode and you can go there. The only one disadvantage is there that we might end with the operational complexity would be there, because it's quite hard to maintain the maximum safety in operation if your same line is going in the kind of divert direction or loop direction and so on. But better rerouting is possible in the integrated lines. So this is the typical example of the independent mass rapid transit system in Singapore. So you can have a look. So that this red line you can see here, but you can also see here that this whole spot is without any mass rapid transit. So it's a very straight alignment, which does not provide any type of a convert divert facilities. If you would like to determine the type of different operation of the independent and kind of integrated, that which one is good, which one is bad. So if we talk about its characteristic, so if there is a number of lines in any route, so we can determine that capacity n divided by 2, while the in the integrated one, we have the formula of n into n minus 1 over 2. And if you talk about the frequency, that how much kind of transit units may be required. So if we have the headway of a 10, so it means that in every 10 minutes, we actually require the transit unit. So our frequency of the transit unit would be 6 transit unit will be required in each hour. So means we will have the capacity of a single transit unit in every 10 minutes. But if we talk about the integrated one, so its capacity may be a bit higher, like 50 minutes. So we may require 1 to 2 transit unit per hour, because in the integrated one, you are kind of to complete your journey, you have multiple options. In the independent one, we have mini transfer, but in the integrated one, from the same line, you can even change to the another line. Okay. And of course, network is a bit more complicated in the integrated one, while the independent is quite simple because it's only go in the same line. If we talk about rolling stock utilization, so the same engine could be used for different purpose for the maximum network wide length purpose. Its best example is under uh, underbahn system of the Prague city. So you can have a look. So the same city is actually divided in only 3 lines, which function on the completely independent line. As you can see here, different type of a transit network, tram network, connected different areas with different branch lines, feeder lines, which converge, diverge from the different areas which connect with the mass rapid is connected with the light rail transit, which is again connected with the different type of a buses classes, such as BRT and regular buses.